Hello, I'm going to walk through the first tutorial of the Marlowe Starter Kit. The first three tutorials are actually zero coupon bond contracts, and we're going to show you three different ways to run those. One is using the Marlowe Runtime services at the command line. The second way is using the runtime services on the web via a REST API, and the other way is using them at the command line, but not using Marlowe Runtime. So it's a lighter weight way of doing things, but you also have to manage your own UTXOs. So for this demonstration, we need Marlowe Runtime backend services. There are a couple ways to get those running. One is through Demeter Run, which is cloud hosting that has an extension for Marlowe Runtime. Another way is to run things locally with Docker. And so I've actually started the Docker instance, and we have that all synced, and we're going to show how to do it with that. And we're going to use a Jupyter Notebook. You can use the Jupyter Notebooks either within Demeter Run or launched locally. So to launch them locally, we clone the starter kit GitHub repo, go into the top folder, and just say nix run. So I'm going to do that now. And this will build the Jupyter Lab server and then launch it. Okay, there we go. It's open the web page for the Jupyter Notebook. And you'll notice we have a special bash kernel that has the Marlowe tools pre-installed in it. So that's basically the kernel we're going to be using. And then you can see notebooks for the different tutorials. We're doing the first one, the runtime CLI, and we're going to clear all the cells here so we can kind of start fresh. And so we're starting with a zero coupon bond. It's basically a loan where someone loans principal and then at a later time they get paid back principal and interest. So in Marlowe Playground, you can build this. There's actually an example you can open there where you have the principal deposited by a lender, the borrower receives it, it's all measured in ADA, and then later on the borrower pays back the interest and the principal, and then that's actually sent to the lender. So very simple contract. That's why we're starting out with that one in the first lesson. And so in Blockly, it looks like this. In Marlowe format, it looks like this. You can go to Marlowe Playground and experiment with this. And you can also do it in Haskell or TypeScript. So to actually run these contracts, we need a couple things to access the node socket and the Marlowe proxy server. So those are embodied in 4 environment variables listed here. And then we need keys and addresses for the parties. So we have a lender and a borrower, and then we have folders where we've previously created the keys, and they've each been funded with 1,000 ADA, and we'll check that. So for convenience, we're going to set some other environment variables just to make sure everything's easy to run and that we can do it independent of whether we're using a cloud service or the Docker service. So first we execute this cell, and it's going to print out just some information. So here's where the node socket is. We're using the pre-production test network, which has magic number 1. We're running locally, and here's the port where the Marlowe Runtime proxy service is living. So let's load these addresses. Here's the address of the lender. Let's make sure that they have at least 100 ADA. They actually have 1,000 ADA. That's a billion Loveless. So you can see that here. And then we can also use the Cardano Explorers to look at things. So if I click on here, you can see that they have 1,000 ADA at that address. So it's just another way of viewing what's going on the blockchain. So we'll create the borrower address, just make sure they have enough ADA to run this example. And then if we did want to look on an Explorer. There's the URL. So first we have to design the contract. And so we're going to use 80 ADA of principal and 5 ADA of interest. And so we'll once again use environment variables for that because it's just saving a little bit of typing and less error prone. And now when you put a Marlowe contract initially on the blockchain, you actually have to put some ADA in it. There's a ledger rule called minimum UTXO. So we're just going to put a nominal 2 ADA in that. And so that'll basically live in the contract the whole time just to kind of keep it on the blockchain. And we're going to be having a deadline, so we actually need to do some computations with time. So we're defining seconds, minutes, hours in terms of POSIX milliseconds, and then we'll just see what time it is now. That's the blockchain-friendly representation of time, and there's the human-friendly equivalent. And the contract has 2 deadlines. One is for the lender to deposit the ADA that's going to be lent, and the other is for the borrower to pay back the principal and interest. So we have those 2 variables defined. And then we could build this in the Marlowe Playground, but Marlowe CLI actually has a handy tool with some templates for different contracts. And so in this case, we're just going to generate it that way. And so we've stored the output in a contract JSON file and an initial state JSON file. And we've put in all the parameters for that here. And if you want to create other contracts, you can use the help command, or you can see what the meaning of these different parameters are, but they're pretty straightforward for this contract. The other thing we can do is actually look at the contract. So here's the contract we just created. It's a JSON file, but I'm printing it in YAML format because that's a little bit easier to read. And so you see the various Marlowe constructs. And so it doesn't matter how you create this contract file. You can use Playground, you can use Haskell, you can just type it in by hand. You can use Go or Rust or whatever tool you want that can output JSON. And then it's always good to check the safety of the contract. This is such a simple contract that it's quite safe, but there are best practices for making safe contracts, and you should pretty much always do this if you're running on mainnet. So you really do need to understand the Marlowe language and Cardano's UTXO model. We have a best practices guide that tells you about how to create safe contracts, and a security guide about what to worry about, what to check. And the Marlowe Playground actually gives you a lot of help here. It has static analysis tools and simulation tools so that you can see what might be wrong with your contract. So even though Marlowe is a safe language, it is a powerful language, so you can create a contract that might not do what you intend it to do. We also have an analyze tool that will study the contract for you and print out potential problems. And then the reason the Cardano testnets exists is so people can try out things like smart contracts and see that they're running properly before putting them on mainnet. So in this case, a best practice is to run all possible execution paths of your contract on a test net before you ever try it on the main network. So we're actually going to do step 6, which is the analyze tool, just so you can see what that does. And first we have to sort of bundle the contract and its initial state into a Marlowe file. So we just did that. And then we're going to run the analyze tool. So what this tool does is it looks at the contract and it figures out all possible execution paths, like all possible future operations of the contract, and it checks each transaction that might occur in the future. So this is basically 100% coverage of what the contract might do. And it's checking a bunch of things to make sure you haven't made a mistake with your the names of parties or addresses or native tokens, things like that, that the transaction, the output value won't exceed the ledger parameters, either the min UTXO requirement or the maximum value requirement, or the Plutus execution costs, or just the transaction size. So you get a lot of statistics here, but basically there are no problems, nothing's invalid. You have a lot of falses on the invalid. The contract initially has to start out with at least 1.12 ADA in it. We're starting with 2 ADA, so we're safe there. And no matter which path you're going down the contract, you're never going to use more than 47% of the Plutus memory limit or 17% of the Plutus step limit. So you're fine on the Plutus cost there. And it's only about 1.5 kilobytes. So it's only using 9% or about 10% of the budget for storing a contract on the chain. So we're in really good shape there, but it's always good to check. And so first we're going to create the contract. And the Marlowe Runtime command line tool has a create command. You can read all about it. It's got a lot of parameters. We're only going to use a couple of them here. And essentially what we're doing is we're saying we want to create the contract on the blockchain. Here's the actual JSON file that has the contract. Here's that 2 ADA minimum UTXO that we're starting with. And the lender is going to be the person who creates this contract. So we want the change from the transaction after the fees and things are paid to go back to the lender into their wallet. We're going to store this in a file called tx1.unsigned. So that's an unsigned transaction file. And so by executing this, we're actually calling the Marlowe Runtime backend. It's created this file and it's stored, or it's given us the contract ID. And this is how we identify the contract throughout its life cycle. We can take a peek at the unsigned transaction. It's just a bunch of bytes. It's the CBOR for the transaction. We see it's a body, a transaction body for Babbage. And then we have the question of how do you actually sign this and submit this? So there are a lot of ways to do this. You can use Cardano CLI, which lets you sign and submit transactions. The Cardano wallet at the command line lets you do that. And it also has a REST service, so you can do that on the web with the right authorization tokens and things. There's a command line tool for hardware wallets. Any of the SIP30 wallets that are compatible with Babbage can be used to sign it. And then there's a Marlowe tool, Marlowe CLI, that can sign it too. And so there are a lot of ways to sign things. For this tutorial, we're actually going to use the command line tool here just for convenience. So we tell it we're going to submit a transaction. We give it that file that Marlowe Runtime just created. We give it the signing key for the lender because they're operating this initially here. We're going to wait 600 seconds for a confirmation from the blockchain, and that's plenty of time. And then we're submitting it. So this is basically signing it and submitting it in one go. That's why it's a little bit convenient. A lot of the other tools you have to sign and submit separately. So it takes between like 2 and 20 seconds, or maybe even a minute sometimes, for the transaction to get its first confirmation on these test networks. So here's the transaction. We can see where to go on a Cardano Explorer to look at it. And then we can also just query at the command line to see the transaction. So this is the 2 Lovelace, or the 2 ADA that's stored in the Marlowe contract at the Marlowe contract address. And there's the hash of the datum that actually contains the contract. So let's take a look at the Explorer. You can see this. It's fresh, so it has 0 confirmations. We started with 1,000 ADA, and we used a little bit, about 0.2 ADA, to get this on the blockchain. You can see the 1,000 ADA being spent. We're getting 997.8 ADA change. 2 is going into the contract. This little symbol shows you that, and you can even see the datum there. And so that's the transaction. Okay, so we have the transaction on the blockchain. What if we want to actually look at it? So Marlowe Runtime can inspect contracts. It's always indexing them as they appear on the blockchain. And so this log command will tell us about this contract ID. And we say show contract because it'll be kind of verbose and give us a lot of information about it. Gives us the history of where the transaction was created. And then you can see it's printed out the contract in Marlowe format. We have other tools that can give you even more detail. There's one called Marlowe Pipe, and it does kind of a full dump of the contract in JSON format. We convert this to YAML, and you can read this, but it's essentially what we put on so we can verify that the creation worked correctly. Now, the next thing is the lender has to deposit the principal into the contract. So Marlowe Runtime command line has a deposit command. You can read about that. It basically gives you all the information needed to construct this. Essentially, what we do is we say, here's the contract ID. It's going from the lender into the lender's internal account in the Marlowe contract. So this deposit has to follow the rules of the contract. It'll be rejected if it doesn't. We're putting the principal in terms of Loveless, and the lender is going to be operating this transaction, so they'll get the change that's left over, and this is tx2.unsigned. So we're just going to run that, and then so this has gone out to the backend services, and this is the transaction ID that will be on the blockchain when we actually submit it. Let's say that we didn't do things right. Like, let's say we put 80 Loveless instead of 80 Ada here. You're going to get a no match error. And whenever you get this, what it means is that you're not obeying the rule of the contract. So Marlowe Runtime will not build that transaction for you. Even if you built it, you couldn't get it on the blockchain because the Marlowe validator would reject it. The node would reject it. So that's kind of what happens if you make a mistake. Here's a different mistake where the lender's making the deposit, but they're depositing it into the wrong internal account. And so you see that, you get the same thing. And so we have a lot of help if you're running into trouble creating transactions. There's actually a debugging cookbook that you can visit that lists all the error messages and gives you some things to think about timeouts and stuff like that. But the really convenient way is to use the Marlowe Playground because it has a simulator. So you can actually run through the contract by clicking through and entering data and see the contract operate. And basically, if it runs in the simulator, you can mimic that with your command line. So basically, there's a one-to-one correspondence between these actions here and what's legal to do at the command line. So anyway, we're in good shape on this one because the original correct deposit did work. And so now we're just going to do what we did before and submit this transaction. But once again, we're going to have to wait a little bit for it to be confirmed. And then we're going to view it in the Explorer. Okay, and there's the transaction ID. So once again, we could look at that in an Explorer, and then we can query directly so we see the lender is down about 82 ADA because there was a 2 ADA deposit in the contract plus the 80 of principal. The borrower has an additional 80 ADA in addition to their original 1,000. And the contract still has to ADA at its address, but the hash of the datum is different. So let's take a look at the Cardano Explorer. Now, sometimes there's a lag before the explorers have transactions visible. So we might have to press refresh a little bit here before it appears. Okay, there it is. And we can see the fee was a little bit higher here because this is a Plutus execution. And but you can see the original 2 ADA was consumed from the contract address, and then it still has 2 ADA. The wallet had 997 and went down to 917, so it's down 80 ADA plus the fee for the transaction, and that 80 ADA has gone to the address of the borrower. So you can even click there, and you can see now they have 1,080. So anyway, things are working fine, and once again, we can look at the contract either with the Marlowe Runtime command line and see that now we have 2 transactions. This was the original. And then here we have the deposit. You can see the information on the deposit. And then, Marlowe contracts are kind of like an onion where you're peeling away to get to the center. And so the remaining part of the contract that hasn't been executed is here. It's smaller than the original contract because some of it has already been done and you can't go backwards in a Marlowe contract. And we can also use the Marlowe pipe command and see like a lot more detail and things here. Okay, the third transaction. Now the borrower needs to repay the loan, both the principal and the interest. So this is the same sort of deposit transaction we had before, except now the borrower is doing it and they're getting the change and they're giving principal plus interest. We can submit that, and then we're going to be able to look at it on the blockchain. And that's basically completing the contract. So the confirmation occurred really quickly there. Here's the link. You can see that the lender now has 87 extra. They got their 80 back. They got the 2 they deposited originally in the contract, and they got their 5 ADA of interest. So they have 87. And so their total is about 5 above the 1,000 that they started with. And then the borrower, they have, if you total this up, they have about 995 ADA. We'll take a look at that in a second here. So let's look at it in the Blockchain Explorer. Once again, we need to wait a little bit. There it is. And you can see exactly this transaction. So the borrower, they had 1,000. They consumed what was at the contract, which was 2, and then 87 of that went to the lender, and they were left with the change. So if you click on their address, you can see they're about 5 ADA down, a little more because of the fees. And if you click on the address of the lender, you can see they're about 5 ADA up, not accounting for the fees. So that's what we have there. And we can take another look at the contract. You're going to see 3 transactions. There's the first, the second, and the third one. There's no more contract because the contract is done. So it just records the deposit. It says it's closed. And then if you wanted a lot of detail, you could walk through this too and see basically everything that went on in that contract. So that's how to run a Marlowe contract using the runtime CLI. The second example will be using the web API with REST.